In this video, we're going to see how to find the minimum or maximum value of a quadratic equation. If a parabola opens up, then it's going to have a minimum value or a lowest point. If a parabola opens down, then it has a maximum value or a highest point. So we're going to look back at some images that we made earlier. So this is a parabola that opens up on the left. This one has a minimum at the vertex because the vertex is the lowest point on the graph. Notice there's no highest point on the graph because the values on either sides are just going to keep on getting higher and higher. If the parabola opens down, the vertex is the highest point on the graph. It's the maximum, and then there's no minimum point because on both sides these arrows are pointing downward, so the parabola is just going to keep going down. So we're going to look at example 5. It says to consider the quadratic function f of x equals negative 3x squared plus 6x minus 13. And part A says to determine without graphing whether the function has a minimum value or a maximum value. So what I'm going to do to figure this out is determine whether the parabola opens up or opens down. And so I need to look at the value of A, the leading coefficient. In this case, A equals negative 3. So that means that it's negative. And that means that the parabola opens down. And since the parabola opens down, that tells me that it's going to have a maximum value, because the vertex is going to be the highest point on the parabola. And then part B says to find the minimum or maximum value and determine where it occurs. For a quadratic function, the minimum or maximum, in this case it's going to be the maximum, always occurs at the vertex. So basically this is just asking us to find the vertex of the parabola. Now this equation is given in standard form, so to find the vertex, I need to use x equals negative b over 2a to find the x-coordinate and then plug in to find the y-coordinate. So my a here is negative 3, my b is positive 6. So I'm going to plug in negative 6 over 2 times negative 3 equals negative 6 over negative 6, which equals positive 1. And I need to find the y-coordinate here by plugging in. So I'm going to plug into my equation, plug in 1 for x. So it's negative 3 times 1 squared plus 6 times 1 minus 13. And then do the math here. 1 squared is 1. 6 times 1 is 6. So we have negative 3 plus 6 minus 13, which equals negative 10. So the way that this is going to look in the homework is that there's going to be a sentence for you to fill in. So it's going to look like this. The maximum value. Now, when they talk about maximum value or minimum value, what they're referring to is the y-coordinate. So it's the maximum or minimum y-coordinate that the parabola reaches. So in this case, it's a maximum, and the y-coordinate is -10 at the vertex. So that means that the largest y-coordinate on the parabola is -10. So the maximum value is -10. It occurs at x equals 1. So this is fill in the blank in the homework. You fill in the maximum value where you put the y-coordinate and then you put the x-coordinate. So next you should do checkpoint problem number 5. It says to repeat parts A and B of example 5. There's also a part C, which you'll see in the book, but you don't have to worry about that for this class, just parts A and B, using a different quadratic equation. So do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to look at one of the homework problems from the textbook. This is number 70. If you look in the homework problems part, there's no example that is like this, so I wanted to do this homework problem for you so that you could see how it works. There will be a similar problem in the homework in my math lab. So for this problem, it says Virtual Fido is a company that makes electronic virtual pets. The fixed weekly cost is $3,000. And variable costs for each pet are $20. Part A says to let X represent the number of virtual pets made and sold each week. Write the weekly cost function C for Virtual Fido. So this is review from stuff that we did back in chapter 3, writing cost functions. Cost function is the fixed cost plus the variable costs. Fixed costs are $3,000. And then variable costs are $20 per pet, so that means I multiply 20 by the number of pets that I'm making, and then I add those two together to get the total costs. So cost function equals 3,000 plus 20x. So that's review. Part B says the function r of x equals -x squared plus 1,000x describes the money that Virtual Fido takes in each week from the sale of X virtual pets. So this is a little different from when we did this earlier. Before, when we did revenue functions, we had a fixed price and we just multiplied the number of products times the price. This is a little bit different because now my price is variable, and without getting too much into the econ, the price here is going to depend on the demand for the product. But they're giving me the revenue function, so all I'm going to do is use it to compute the profit function. So I need to remember that profit equals revenue minus costs. You take the money that you have coming in, you subtract the money that you're spending, and that gives you the leftover amount of money. That's your profit. So I can substitute. My revenue function is -x squared plus 1,000x minus the cost function, which I'm going to put in parentheses, which is 3,000 plus 20x. And then now I want to simplify this and combine like terms. First, I'm going to distribute the minus sign here. So -x squared plus 1,000x minus 3,000 minus 20x, and then combine these two like terms, 1,000x minus 20x. That's going to give me plus 980x. So this is my profit function for Virtual Fido. Now part C says to use the profit function to determine the number of virtual pets that should be made and sold each week to maximize profit. What is the maximum weekly profit? So because this profit function that I have up here has a negative leading coefficient, -1 in front of x squared, that tells me that it's going to open downward, so it's going to have a maximum value. So what I'm going to do is again use my x equals negative b over 2a to find the x-coordinate of the vertex, and then I'm going to find the y-coordinate. So my a here is negative 1, my b is 980, my c is negative 3000. So I'm going to plug in 980 for b, negative 1 for a. Now I have negative divided by negative here, which is going to give me a positive number. It wouldn't really make sense to have a negative number of products to make. So when I divide these, I get 490. So remember, x is number of products, and that tells me that I need to make 490 products in order to maximize profit. To answer the second part of the question, what is the maximum weekly profit, I plug into the profit function. So profit, when I make 490 pets, I'm going to plug in 490 for x. And then do the math here. So you can type this all into your calculator or do it piece by piece. Make sure you square 490 and then make it negative here. Plus, this is going to be 480,200 minus 3,000. When you add all that together, you get 237,100. So that's the profit, that's in dollars. And that's the most profit that I can make. And I make that profit when I make and sell 490 virtual pets. So the maximum weekly profit is 237,100 when 490 pets are made and sold. Remember, we have an underlying assumption here that everything we're making, we're selling. That's an assumption in writing costs and profit functions. So that's the answer for part C. So there's no checkpoint for this one, but you should now go and look at the homework for this section.